In this lesson, we are going to learn the volume of known cross-sections. So if we have fixed cross-sections, the cross-section will be perpendicular to x-axis or y-axis. If the cross-section is perpendicular to the x-axis, the integration will be along dx, and inside the area will be a of x. And if it's perpendicular to y-axis, we are going to use dy, and inside will be a function of y. So generally speaking, the volume will be the base area times the height. And the height in this case will be dx or dy, depends on which direction you are integrating along. And the base area will be a function of x or function of y. There are some special fixed cross-sections we have to be very careful. So if the base is a square, if it's a square b, the base area will be b squared. If it's a rectangle, it will be b times h. Base times the height, and height will be a given function. So you can relate the height to the base. Semicircle, given semicircle here, the base, if the base is the diameter, the base area is given by pi times b squared over 8. The radius equals b over 2. Equilateral triangle. So if any of the side is our base, the area will be square root of 3 times b squared over 4. For isosceles triangle, there are two cases. If we put the hypotenuse as our base, then the area will be b squared over 4. If the leg, one of the legs is the base, then the area will be b squared over 2. So everybody keep in mind, all the b's will be a function of x or a function of y. Basic steps are, first, you have to sketch the base of the solid, and also what's the fixed cross-section, what shape is that. Next, find the formula for ax or ay, then integrate it to find the volume. Integration ax dx or integration ay dy. Let me go over some examples. Let's look at example 1. So a solid has a base that is a circle. So this is the base we are integrating on. The equation of the circle is given by x squared plus y squared equals 1. And the cross-section perpendicular to the x-axis are semicircles. So there will be a semicircle here if you look at the picture. Each cross-section are semicircles with their diameter in the plane. So the diameter is given by, this is our base. Find the volume of the solid. If you look at this one, the integration, we are going to integrate along the x direction from -1 to 1. So integration from -1 d of x. Inside will be the area of function of x. The area will be the semicircle area, which is pi b of x squared over 8. Now what is b? So if you look at here, this is our b, that's the function of x, which will be the distance between a and b. So a minus b, if you look at here, what's point a? Point a, y equals square root of 1 minus x squared. Point b, because b is below x-axis, so y will be negative 1 minus x squared. Everything is from here, you just solve for y. So now the distance will be the height, basically the distance between a and b will be 2 square root of 1 minus x squared, which is b equals point a minus point b equals this minus negative, give us twice x squared. This has to be a function of x inside. Let's look at example 2. The base of the solid is region bounded by the graph x equals y squared. This is a parabola, x equals y squared, and the line x equals 4. The cross-section perpendicular to the y-axis are squares. Those are the cross-section are squares. So if you draw a random cross-section, this is our base. So the volume will be given by x from 0 to 4. We are going to integrate along x direction, 0 to 4. The base area will be a function of x, and we know for the square will be b squared inside. B has to be a function of x. So in this case, what is the b value here? B will be the height from here. So this one will be y equals square root of x. This is y equals 0. So square root of x squared dx. Same problem if we integrate this along the y direction. If our cross-section perpendicular to the y-axis. Okay, so in this case, the volume will be integration. Y will be from 0 to 2 when x equals 4, y equals 2. So b of y squared dy. In this case, this is our b. So this is x equals 4. This is x equals y squared. So the distance between these 2 points will be 0 to 2, 4 minus y squared, squared dy. Sometimes the picture or the graph is not given. You have to be able to sketch the graph yourself. Let's look at example 3 together. So example 3. The base of the solid region enclosed by the graph y equals x squared, parabola, and the equation of a line. Let's have a look at the graph. The graph y equals x squared. Y equals x plus 2. There will be 2 intersections. So first, let's have a look at the intersection. X plus 2, we set them equal. X squared equals x plus 2. So x factoried -1 and positive 2. This is our solid. And along the solid, we are going to have the right triangle, isosceles triangle, because they didn't tell us it's the base one of the leg or the hypotenuse. Let's have a look at both cases. If the base is one of the legs, if the base is the hypotenuse, so the integration will always from x equals -1 to 2, x equals -1 to 2 dx, and the inside will be different. If the leg is the base, the area will be b squared over 2. If the hypotenuse will be the leg, will be b squared over 4. And b is a function of x. So this will be from -1 to 2, b. This between a and b. For point A, y equals x plus 1. For point B, y equals x squared. So this one will be a minus b, which is x plus 1 minus x squared squared. Same thing, x minus 1, x plus 1 minus x squared squared over 4.